Assalamualaikum and hi, my name is Muhammad Zumiftar Bijakaria with the ID number of 1800235 and for today I'm going to present about Bernoulli experiment lab report. Okay, for this lab report we are going to cover 5 contents, which is introductions, objective, apparatus and procedures, experimental results, and last but not least the discussions and conclusions. Alright, so we will start with the introductions first. So what is Bernoulli's principle? So Bernoulli principles was introduced by Daniel Bernoulli, a scientist, whereas he said that when area available for the fluid to flow decrease, then the flow velocity of the fluid will also increase, and at the same time the fluid pressure or the fluid potential energy will decrease also. So in a steady flowing fluid, or the rate of flowing fluid in any sections is constant, the sum of all the mechanical energies including kinetic energy, dynamic head, fluid pressure, and potential energy should remain same at all the point of the flow. And so from Bernoulli principle, there are a few applications that have been applied, such as a flight, lift, baseball, draft, and sailing. Alright, so based on the statements, Bernoulli equations could be written in the form of variables and equations. So Bernoulli equations are very important in fluid mechanics as it covers pressure, velocity, and elevations. Bernoulli's theorems assumes that the flow is frictionless, steady, and incompressible along same streamline. These assumptions are also based on the laws of conservation of mass and energy. Alright, so the objective for the lab experiment itself is going to be to use the venturimeter apparatus to study the effect of area, of the flow of the velocity, and the fluid pressure itself. Moving on, so this is the apparatus and the procedure. So for these experiments, we are in need of venturimeter, supply hoses, measuring tank, basin, and manometer tubes. Alright, moving on. So this is the procedures. As you can see, there is the setup of the apparatus for the experiment. So first of all, place the venturimeter onto a horizontal surface and note the height of the input valve and the output valve and make sure that they are the same. And next, attach the apparatus with the power or water supply, but keep the supply off first. And then open all the air bleed valve of the manometer present at the top, as you can see there. And then supply the water based on the power supply or the machines and adjust the flow rate control valve until water level in all of the manometers is at readable range, and place the stop plug in basin and note the time required to fill in the basin with water. Alright, moving on, remove the stop plug to drain out all the water, and then place the dynamic pressure probe with the static pressure pod and measure the manometer data from both of the probes. Now, place the dynamic pressure probe with the next static pressure probe and measure the manometer data from the probes. And last but not least, repeat the above step for measuring data from all of the manometer probes. Okay, with that being in mind, so next we are discussing the experimental result. So this is the templates for the results. Whereas as we can see here, we could have the data of time, pressure head, total head, flow rate, velocity, pressure head, velocity head, calculated total head, and measure total head. And then, with that, this is the sample calculations, whereas we used the equations from the previous slide of the Bernoulli equations, and we will calculate the experimental data, and then we will calculate the theoretical data, and we will compare it whether it is same or not. Alright, so here as we can see, this is the data samples. Okay, so here wise there is a curve here. As pre-mentioned before, when the volume or the area decrease, the velocity will increase, but the pressure will decrease along with the area itself. And moving on, this is the comparison between the theoretical values and the experimental values of our experiment. So last but not least, the discussions and the conclusions. So from the conclusion, it is very clear that with decrease in area of the flow, velocity will increase but the pressure will decrease. And as shown in the graph of all three tests, that the decrease in area of flow decrease the height of water in manometer columns, mean they are directly proportional to each other. And the difference in the theoretical and measured value, it can be said that water is not an ideal fluid. And last but not least, the height of water in the final column was not equal to the initial values, which shows that there are a friction loss in the water particle itself. So, all in all, we achieve and successfully execute the experiment itself, and we achieve the objective where we want to prove and wants to investigate the Bernoulli's principles, whereas we can conclude that decrease in an area of flow, there is an increase in velocity and decrease in the flow pressure of the fluid itself. So all in all, that's all from me. Thank you. And that's all for the Bernoulli's experiment.